Calculus video 13, left and right hand limits. So we often talk about left hand limit and right hand limit. The left hand limit, or LHL, left hand limit, often referred to as the limit from the left. Left hand limit, limit from the left means the same thing. The notation we use for that is over here, the limit as x approaches a, and it's got a superscript of a minus sign. It's like a minus sign in the exponent of a. That means the limit from the left, right? Not negative necessarily, just from the left. So the limit as x approaches a from the left of a function. So what you're thinking about there is if you have a graph, right, some curve, here's your value a. Maybe that curve's defined, maybe there's a hole in the graph, right? What you're picturing is, what is the y value doing as x approaches a from the left? That's the left-hand limit. The right-hand limit, or RHL, or limit from the right, same idea here, where we have the limit as x approaches a with a plus sign in the superscript of a, right? Kind of like an exponent, but it just means from the right of our function. And so what we're thinking there is, as x approaches the value of a from the right, what is the y value doing? Right? That's the limit as from the right, or the right-hand limit. Negative sign on the exponent of a, left-hand limit, plus sign, right-hand limit. And we also have what's called the overall limit, right? The overall limit, or just the limit of the function, is when we do not have the superscript. It's what we've been doing so far. The limit as x approaches a of f of x. And when you see that, what that really means is it's coming from both sides. So the limit as x approaches a, or the overall limit of the function, is what is the y value getting close to as x approaches a from both sides. All right, so when you picture that one, just the overall limit, you're thinking from the left-hand side and from the right-hand side, what is the y value going to? And for that overall limit to exist, for the limit as x approaches a without a superscript of plus or minus of the function to exist, three things must occur. First of all, your left-hand limit must exist. You have to have some curve that you're approaching the value of a from the left. The right-hand limit must exist, and the left-hand limit and the right-hand limit must be equal. It should look like the picture I have right up here. This overall limit exists because as we approach a from the left and we approach a from the right, both of them approach this y value of L. The left-hand limit and the right-hand limit are coming together, if you will. What would not exist? So, limit does not exist. You know, something like this, where the left-hand limit, so if this is a here, the left-hand limit coming and looking here, but the right-hand limit may be up here, right? So as we approach the value of a from the left, it's getting towards this particular y value L here. But as we approach the value of a, say, from the right, it's getting towards this value of y here, k. And since L and K are not the same, is where it's approaching from the left is not going to the same place, some y value, as the function approaching from the right, the overall function does not exist. Now let's be careful here. The left-hand limit exists and equals L. The right-hand limit exists and equals K. But since those two are not equal, the overall limit does not exist. All right, so in this particular case, I would write something like this. The limit as x approaches a from the left of our particular function equals L. The limit as x approaches a from the right of our function is equal to k. But the limit as x approaches a, the overall limit of our function, does not exist. And the reason it does not exist is L and K are not the same, and we can abbreviate that like this. The left-hand limit is not equal to the right-hand limit. Very good. So that's one way where the limit would not exist. Okay, so I've just kind of drawn here, similar to that I did up there at the top, where the left-hand limit in red is approaching a particular value, the right-hand limit in green approaching the same value. This would be a case where the limit does exist. What are some other cases where the limit would not exist? All right, we did one, right, up here where we had called it like a jump in the graph. The limit would not exist there. You'll see that when we do piecewise defined functions sometimes. Another place where the limit would not exist is at an endpoint. This one's interesting and often throws people. Let's say I have like a graph that starts right here and looks like that, kind of like a square root graph, right? And this endpoint is my value A. This one throws people off because they see the endpoint and they see this value A, and you could actually do direct substitution and it messes you up. So for example here, the limit as x approaches A, the overall limit of our function, let me just go ahead and name this function. Let's call this looks like the square root of x plus 3 plus 1. And the A value, it must be going there, must be at, say, negative 3. Now, it looks like you can do this. It looks like, okay, here's let me erase this A down here and put negative 3 instead. All right, so as x is approaching negative 3, if you don't think about what the graph looks like here, you might be tempted to plug negative 3 in and say negative 3 plus 3, that's 0. Square root of 0 is 0. Plus 1 is 1, and therefore the answer is 1. And that would be wrong. It's wrong. Because in order for the overall limit to exist, as x approaches negative 3, both the left-hand limit must exist and the right-hand limit must exist, and they must go to the same thing. In this case, the limit as x approaches negative 3 of our function, squared x plus 3 plus 1, does not exist. The overall limit does not exist. And the reason is, even though the limit from the right exists, the limit as x approaches negative 3 from the right does in fact equal 1, right? Instead of L there, I probably should have put 1. As we approach from the right, we see the y value is in fact getting closer and closer to 1. So from the right, the limit does equal 1. But from the left, we have a problem. Try, on the graph that I've drawn here, to approach the x value of negative 3 from the left. You can't, because there is nothing over here. The function is not defined for x less than negative 3. It's undefined. You're taking square roots of negative. That's an undefined thing. The limit as x approaches negative 3 from the left does not exist. And since the limit doesn't exist from the left, remember our definition up here, in order for the overall function, the overall limit to exist, the left-hand limit must have existed, the right-hand limit must have existed, and the two must be equal. Since we did not have a left-hand limit existing, that means the overall limit did not exist as well. So be careful at endpoints is what I'm saying here. Be careful at endpoints. Okay, let's take a look at one more. How about the limit as x goes to 4 of 3 over x minus 4? Okay, what's happening in our function here? 3 over x minus 4, we should know what that looks like. That's a rational function. You should have a vertical asymptote at 4, at x equals 4. Because if x is 4, you're taking denominator 0. 3 divided by 0, that's undefined. That's a vertical asymptote. We have a horizontal asymptote at y equals 0. And we get a curve that looks kind of like this. So what I want to know is, what is the limit as x approaches 4? And what you should be thinking, because it's an overall limit, is, well, what happens on the left-hand side? What's that going? That looks like it's going down to negative infinity. What happens on the right-hand side as we get close to, this is a value of 4 right here, as we get close to an x value of 4, the y values go up to positive infinity. So does the left-hand side and the right-hand side go to the same thing? No, they do not. Therefore, the answer here is does not exist, because the left-hand limit does not equal the right-hand limit. What we can say is the limit as x approaches 4 from the left goes down to negative infinity, whereas the limit as x approaches 4 from the right goes to positive infinity. Those two aren't the same, so the answer is does not exist. And we actually have a little bit of a not exact answer here when we say goes to infinity, goes to negative infinity, because limits have to approach, by definition, a real number L, and infinity is not a real number L. But I want the information that the positive, from the right is going to infinity and from the left is going to negative infinity. And so we write goes to negative infinity for the left, we write goes to positive infinity for the right. But we should also know that that means that the limit does not exist. It does not exist, but it goes to negative infinity. And the limit here does not exist, but it goes to positive infinity. And so I want you to write the negative infinity and positive infinity, but you should also know that it technically does not exist, because for the limit to exist, by definition, it must go to a real number L, and infinities aren't real numbers. Okay. Very good. How about maybe one more? The limit as x goes to pi over 2 from the left of tangent x. Really, I want to remind you, right, of some of these trig functions and their graphs. You should know what the tangent of x looks like. Let's see, you've got 0, pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. We should know that we have vertical asymptotes at all the pi over 2's for the tangent function, and that the curve looks something like so. So when we look at the limit as x goes to pi over 2 from the left of the tangent of x, so we're going to pi over 2, but from the left, so from the left-hand side, what is happening is it's going up here to positive infinity, so our answer here, positive infinity.